So now let's look at the diametric form of a sphere. So this is the diameter form of a sphere. Now I have here the coordinates of the two ends of a diameter. There are infinite diameter. I just picked up one diameter and I know the end points of this diameter. I don't know anything else about the sphere. I don't know the center. I don't know anything else. But to get the equation, what we will do is we'll once again assume a general point on the sphere, right? And we'll be using a property from your 10th class, and that is basically a diameter subtends an angle 90 degree on the circle. So on a circle also it subtends 90, and on a sphere also, because if you take the cross section of a sphere, if you cut it and you'll get a circle itself, right? So if you cut the sphere along this line AB, you'll get a circle. So the property is still valid here. If you have AB as a diameter, this should subtend an angle 90 degrees. So what I've done is I've created this vector, this pink vector, which starts from A and goes to this R, this point, general point R, right? Let it be R. And the vector which starts from B and goes to R. These two vectors must be at 90 degrees. So what I've done is, this vector is your R bar minus A bar, because it starts from A and goes to R. This vector is R bar minus B bar, because it starts from B and goes to R. The dot product of these two should be 0 because they are at 90 degrees. The dot product of these two should be 0. And this itself forms the equation of your sphere, right? This itself is the equation of the sphere, but in the vectorial form. Now, coming to the Cartesian form. So once again, what I've done is, the coordinates of this are x, y, z. The coordinates of this are x1, y1, z1. The coordinates of this point are x2, y2, z2. So I've written their position vectors using the same thing that we've already been doing for a lot of time now. R bar minus A bar vector is this vector, right, in the Cartesian form now, in the component form. And R bar minus B bar is this vector. Their dot product should be 0, right? I just substituted the same thing in this result, right? And then from this we get this as my final equation, right? This is the equation in the Cartesian form. So here your x1, y1, z1 are the coordinates of your first point of the end of a diameter. x2, y2, z2 are the coordinates of the second point of the end of the diameter, and x, y, z are any general point on the sphere, right? So with this we complete the topic called 3D spheres as well. This is all that we needed to know. The only thing that you need to do is do a lot of practice based on these equations, because your real challenge is dealing with these equations real time. When they come in front of you, you should be able to extract every information that you require according to the question. Or if it comes as a part of some other question, you should be able to extract the required information and move on with the question, right? So these are all the concepts of the 3D geometry. In fact, so we end this chapter also, 3D geometry, with this, because we covered almost everything. So I hope you found this useful. Thanks for watching.